for being here. I appreciate it. Nice seeing everybody. So this is session 4 of the Studio for High Performance Design's Electrification series. Let's see, actually, I'm going to go to the next screen here. So these are kind of all the sessions we've been doing and the ones coming up. So the first 3 on sort of calculating your home's energy use, insulation, air sealing, the building envelope, and the mechanical systems. Those are all recorded and they're up on the studio website at studiohpdc.org. So if you didn't get a chance to see any of those, or you missed parts of them, you can always rewatch them there on the studio website. This session tonight is being recorded as well, and we'll post it up there here later this week for your viewing. The next 2 sessions are there on the screen. So we're going to talk about electric cooking next, or in 2 weeks on the 21st, and then in January we'll talk about PV, batteries, EV charging, and with all these sessions we're kind of open to a lot of topics you guys have as well, and questions you have, and we're going to keep this electrification series going, and there's a lot more topics that we can discuss. I know things around, say, the electrical system of the house have come up, and lots of kind of other questions of things that we can develop entire sessions around. So we'll keep this discussion going, but these are ones we have scheduled right now. So this is the studio itself. Some of you have been there in person. Many of you have just attended these live sessions. We're hoping early next spring to be able to start doing in-person sessions here again at the studio. But that's what it looks like in Newton. Beautiful net zero passive house place there. I'm going to go on. So these are us today. So this is me, Aaron Gunnarsson on the right. On the left is Nick Felkoff, who should be on your screen as well. Nick, you want to wave and say hello?
Hello, thanks for joining us.
Great, thanks, Nick. We've had some other people in the past, Kate Stevenson and Travis Anderson, join us, and they'll be back for some of the future sessions starting in 2 weeks. But tonight, it's going to be me and Nick taking you through most of it. So this is sort of the basic topics that we have, but really we also want to know your questions. So we're going to go through a lot about electric hot water. We're going to talk about a lot about electric heat pump systems for hot water. We'll touch on a few other systems as well as we go through it. But really we're here to also answer your questions. We have a lot of folks here today. You guys are attending this because you're interested in this for some reason. So please let us know what that is. Use the chat room right now if you'd like to, and say kind of what you're concerned about, with what you want to hear about. Ask questions throughout the presentation. We're going to tailor this to what you guys want to hear and what you're curious about. But this is sort of the stuff we're going to go through. We're going to talk a little bit about domestic hot water. So we'll talk about kind of current systems, a little bit about how they work, just so we're kind of all on the same footing of how water systems work in our homes. We'll talk a little bit about solar hot water, which has sort of been a more common-ish system for kind of switching from say a gas water heater. There's some drawbacks to it, and we're not seeing it used as often anymore, but we'll cover it briefly. And then we'll get into heat pump water heaters, which are fast becoming a sort of a larger segment of the market, and really one of the more efficient ways to go from say gas to electric hot water. So we'll definitely cover those in depth here. We'll talk a little bit about like kind of our own experiences through this. But as we kind of go through it again, ask lots of questions, tell us what you like to hear. And yeah, we got some in the comments already. So water heater costs, electric system needs. So we'll talk a little bit about that. We'll cover some of the, do you have to upgrade your panel? How much does this cost? We'll cover a little bit. We have some numbers to go through. This is basically it. So first off, we kind of started every session this way, but again, this is just a prompt for you guys to fill some stuff into the chat room. Let us know what you're curious about. So obviously the overall goal for your home. So feel free to specifically talk about water today, but if you have some other questions from some of the other sessions that you weren't able to get answered, feel free to ask those too, and we'll see what we can get to tonight. So first, I just wanted to give a quick overview of solar hot water. As I said, I would mention it. So these are kind of 2 common solar hot water systems you see in photos here, a flat plate collector system and an evacuated tube collector system. But both methods work pretty similar, where they take the heat, the solar energy from the sun, and use it to warm up water. And they do it in different ways. Most of them rely on a storage tank. So they're pumping water through these collector systems and through these heating systems and putting them into a tank in your home. So you probably are familiar with this. You may have seen them on other places. You may have seen them on someone's homes. They're out there. They're available. There are some drawbacks to them. I know, Nick, you ran into some, so I will let you mention them. But I just wanted to mention a few things on the cost on the top. So the MassCEC, so the Massachusetts Clean Energy Center, has an estimate of around $10,000 to install one of these systems on average home. That's kind of the metric to use. There are some incentives for it. There's not a lot out there for solar hot water anymore, but there are some incentives. So there's a federal tax credit. So you can get up to 26% of the installation cost as a tax credit. That is kind of stepping down in the next few years, but it's at 26 through the end of next year, through 2022 at least. And there's some alternative some alternative energy credits in Massachusetts that you can qualify for. Those are variable, and there's a lot to get into with that, so we're not really going to cover the cost. It can vary quite a bit, but that gives you an idea of what we're looking at here. Nick, do you want to say anything about solar hot water and maybe some of the drawbacks or challenges you've seen?
I know Kate's been working on a multifamily building. We've never installed them in our residential homes. It is an option. I think it's worth putting it out there, but we're mostly moving towards just heat pump water heaters. So I think, yeah, Kate's working on a multifamily building that these are more common, but yeah, I don't have anything to add on them. They seem interesting, but they are expensive, and you have to get up on a roof to install them. So a little more complicated. Yeah.
Yeah. And I think, going back several years ago, while they were really expensive, there weren't a whole lot of other options if you wanted to switch off of a natural gas boiler for heat, or a natural gas on-demand system for heat. If you want to go to electric or some other system, there weren't a whole lot of options. So solar hot water was a popular choice for folks who wanted to reduce their carbon emissions from hot water. But now, thankfully, we have a lot of other options out there, specifically heat pump water heaters. So we'll talk about those. Nick, I'm going to let you take over here for a moment, talk a little bit about how water heaters work and some of the kind of big things that we should know for this discussion.
Sure, thanks, Aaron. So just most of the homes in New England homes are traditional gas hot water heaters. So you've got a burner at the bottom of the tank, and it's heating up a metal plate, and that metal plate is warming up the water. And then you've got the gases are pulling an air up at the top, and it's venting out through a chimney. So you're combusting a gas appliance indoors. This is probably, if I were to guess, I would say this is, probably 70 or 80% of the homes that we work in. This is what you find in New England for water heaters. That's what I have in my own house. When they fail, the heat exchanger at the bottom, rusts out or oxidizes, and the water just pours out of the bottom. So this is very common. That's how they work. I don't know if there's any questions on them. They typically last. You get a 10-year warranty, and they break the day after the warranty ends. Okay. So yeah, pretty basic. Let's go to the next one. Yeah. And just something. And so this is an electric water heater. So a lot of people, I think 40% of the country might be on electric water heaters where you don't have natural gas or propane. So 40% of America runs on just electric water heaters, and that's basically just you're not combusting any gas, you're not venting them. You're really just you're just putting cold water in, and you've got a coil that's just heating up and heating the water. And so, these are less common in New England, but you still see some of them. And these have about 21 gallons of recovery. So, at an hour. So, they recover fairly quick, not as quick as a gas unit. But they're just, you put 1 unit of energy in, and you get 1 unit of energy out. It's like a toaster oven. Okay. And they're okay in certain uses, but they're not super energy efficient. So, those are the two most common types. Let's go to the next slide. One thing, this is going back, to a gas water heater. Sorry, I put this slide out of order. This is an article from Allison Bales, just writing about one of the drawbacks to gas-fired water heaters, he's pointing to the gap on the top of your gas water heaters. That's where it's drafting in the air. That's the flue vent. And they're designed to draw in air and naturally draft up, because the warm air rises. But if the problem is that sometimes if you were to depressurize the room, or if there was very, very windy, or if there was air coming down that flue, those combustion gases can go into the room. So a lot of the stuff we're looking at as we build tighter buildings and we start to monitor our air quality is that, Allison's pointing out that in the article's link down in the footing here, is that you can be putting a lot of bad fumes into your house if your unit's not running correctly or it's not venting properly. So it's just something to be aware of. You don't run into with an electric heat pump water heater.
I think it's a great point. We've talked about air quality in the past in some of these sessions, and I know we'll get into it. We talk about electric cooking in the next session, but this is a big reason why burning natural gas in our basements is causing poor air quality.
Yeah, we'll link all the articles we mentioned. Aaron put a link of all the resources at the end. So if we mention an article, we'll link it at the end so you can.
Yeah, and this one's, there's a link at the bottom there of this one too. So
yeah. So this is just a graphic of a basic heat pump water heater. And so when people say, well, what's the difference? So a heat pump water heater has a condenser basically on the top of the unit, and it's pulling in air at the top of the unit, and then it's taking the heat out of the air and it's putting it into the water. So this is what we call an air to water transfer, right? We're taking the energy out of the air or putting it into the water. So and basically that condenser works just like your air conditioner. So if you imagine you've got a little mini air conditioner sitting on the top of your water heater that's got refrigerant pumping through it, right? And just like your air conditioner, takes the heat out of the box, puts it outside of your house, dumps it outside. This is taking the heat out of the air and it's putting the cold air into the room, and the warm air is going, the warmth is going into the water. So it's heating the water and it's cooling the room. Okay, and they do, because it's a condenser, just like air conditioners will condense vapor, they do have a condensate drain because they will pull some moisture out of the air. They don't do a ton of dehumidification, but they do a little bit of dehumidification. And then the item 8 is the backup electric heating element. So sometimes if you have a very high demand, so let's say you had a bunch of guests, or you have teenagers that take 40-minute showers and they're burning through your hot water demand, and you need a lot of hot water quickly, the heat pump can't necessarily keep up with a 40-gallon per hour demand. So if you have a 20-minute shower at 2 gallons a minute, you're going through 40 gallons. Somebody else wants to take a shower afterwards, the heat pump can't necessarily pull all the heat out of the air fast enough to meet that demand. And so the heat pump will kick over to the electric backup. I think Kate mentions, like, Kate's in Vermont and she's got a heat pump water heater. And in Vermont, she has an unheated basement. So that basement can be fairly cold sometimes, and it'll just kick over to electric as needed. So it's not all the time, but it's occasionally. So these are sort of hybrid systems. It's a heat pump and it's an electric water heater. Any questions on just overview of it, what a heat pump water heater is, or how the components work? We're going to get into some more of them. Why don't we go to the next one slide, Aaron, and we'll see if anything else comes up. So one thing we run into with these, because we install these in pretty much all the homes we build, is recovery time. So as I said, a hybrid heater, it uses electricity and the heat pump. We use the Ream units or RUD. They're basically, I think, the same company. And we put in 40, 50-gallon units. You can put in 80 gallons. Some of our bigger homes will put 2 80-gallon heat pump water heaters. And they both have recovery time, so 21 gallons per hour. But we have some of our clients who are families and they've got kids, and the kids take really long showers, and it will zap those water heaters, right? So what we're going to talk about later in the session is how do you size a water heater, and then what is the most efficient way to to size it so you're not heating too much or too little, and what are some of the considerations you have when you put a heat pump water heater in your basement, because this is acting different than a gas unit or electric unit, right? It's actually cooling that space down, and it needs to air around it to keep pulling that heat out of it. So there are space requirements, and I'll kick it back to you, Aaron, and you can talk about these next few points.
Sorry there. Yeah. We're getting some good comments in the chat room too, so we'll try to cover those things folks are putting in there. So I do see those. But first, just give us some kind of numbers, things we'll keep in mind as we talk about water heaters. So tank size, obviously that's a clear one. Usually, measured in gallons when you got to buy one, but how much water do you need? So we'll talk a little bit about how to figure that out. It makes a big difference, if you're a family of 5, or you a retired couple, like what is your water need? It makes a big difference in terms of the cost, in terms of what water heater you'll be buying. Something to look at is getting at what Nick was just saying is the first hour rating. FHR. This is usually something you'll see when you purchase a heater that talks about how long it takes to recover. This gives you an idea of that recovery time. The larger the number, the larger the FHR, the quicker it's going to heat up the tank. So that's kind of a general quick hand for something you want to look for if you need a higher refresh rate or reheating rate, FHR. And then a bigger factor for energy efficiency is the uniform energy factor, UEF. You're going to see pretty much any water heater you look at nowadays is going to have this. So it's going to be rated. You're going to have that number. It's the measure of energy efficiency. Basically what it's telling you is of all the energy you're putting into it, whether the energy is a fossil fuel source or electricity, how much of that energy is going to be converted into actually heat for the water. As you'll see here, most efficient gas systems are anywhere from about 0.65 up to about 0.95. So 0.95 would be 95% efficient. That means they're taking 95% of the energy of the BTUs from natural gas that they're burning and converting that into heat for the water. So they're losing some, but they're converting around 95% of it. When we talk about a heat pump hot water system, though, those are about 2.5 to 3.5 on UEF, or 250% to 350% efficient. They're able to do that because, as Nick said, they're pulling actually some heat. They're using electricity not to directly heat the water, but to pull heat energy out of the air. So they're able to actually produce or get more heat energy than you put into it. So these are some of the big numbers we'll look at. So let's go on.
Aaron,
oh yeah,
one of the questions that came up too is, someone saying they've had a heat pump water heater, and Kate's responding. And it's not that the electric water heaters are bad. It's just that these are so much more efficient, right? So if we're putting in 1 unit of electricity and we're getting 3 out, then, they're just that much more efficient. So it's not that the electrics are bad so much as that they're just, yeah. Sorry.
Yeah, exactly. And I think that's from a practical usage standpoint, that might be the bigger benefit. What you would see is, what your result would be a lower electric bill in general if you had a heat pump heater versus a traditional electric tank heater. The difference to you might not be the water itself or the lifespan of it, but it might be that efficiency, meaning a lower bill for you. So when we look at heat pump water heaters, what are the benefits? So cost savings. So because of that higher efficiency, operating costs can be up to 50% lower than if you're using a traditional electric system like Nick was talking about, oil, propane, gas water heaters. Doesn't say gas for some reason on this list, but we're talking about all these fossil fuel systems. This can reduce, your annual water heater, $200 to $400 cost. That's just an average. I mean, it's an estimate. It all depends on how much water you're using, what your electric rate is, all that's going to impact this. But in general, that's what you can kind of expect. So when you look at the cost of a heat pump water heater, how much you have to pay to install it, think about the fact that every year thereafter, you're going to be saving around $200 to $400. And that's going to quickly add up. And they can also last longer. Now, there was a question in here about the warranties. That might be on traditional electric heaters, because we have seen longer warranties on some of these heat pump heaters just because they can last longer. A lot of them have 10+ year warranties, whereas I know a lot of the old natural gas tanks, might have something even around the 8-year mark or something. Nick, have you seen warranties kind of in that 10+ year rate as well for the Ream units you're getting?
You know what? I have to go and check what the last one was. We haven't had any warranty issues with the Ream or Rudd one, so I would say, so I haven't had to check that, honestly.
Well, that's good.
Yeah.
So functionality. So as Nick mentioned, they do provide dehumidification. It's not a large amount, but there is some dehumidification there. So if you're putting these, say, in a damp basement, it might help with a little bit of dehumidification there. Many of them, have smart features built into them: Wi-Fi controls, leak detection, usage monitoring, kind of all these other features that you might get as add-ons for your current system. A lot of these newer ones haven't built in, and they can also be installed in places other tanks could not. What I mean by this is you can actually get a lot of smaller units that you can put in different places, and I'll show a few examples of those as we go on here. So I'll talk about that one in a moment. And then, of course, greenhouse gas emissions, the big reason, I think the reason we're all talking about electrification in the first place. So these, of course, produce lower greenhouse gas emissions than electric resistance or fossil fuel heaters. And then if you have solar PV, these can be 100% emission free. So some great benefits there. So some considerations, things you kind of want to think about. Here's a Ream unit. These might be similar to what Nick's kind of has experience installing. So unless you kind of go for one of these smaller units that I'll show you in a moment that do have a smaller capacity, your sort of typical units, your 50-gallon or so units are going to be about 60 to 70 inches tall, which might be a little bit larger than a traditional unit. By larger, I generally mean a little taller, so you might need a little bit more headspace. And they have built-in condensers, as Nick was pointing out when he went through how these operate. Those condensers, in order to work properly, need open air around them in order to pull in. So what I, kind of pulled up was 740 cubic feet of open space. That's going to vary depending on, what unit you get, the size of it, and so forth. But that's kind of about average. And then they usually require around 50 to 90 degree temperatures in that area to function properly. So, if you're putting that in your basement or your attic or kind of wherever you have this water heater installed, you want to make sure that temperature is sort of within that range to function efficiently. It doesn't mean it won't function if it's colder than that, but it's going to reduce the efficiency of it. As we mentioned, it's going to cool and dehumidify the area. So getting down here to some of the other considerations, I know this came up in questions, but most models will require 240 volt electricity outlet. They can share that. I've seen many share it with a laundry dryer, for example, but there are now some lower voltage models. So Rheem has some 120 volt models. Nick, have you installed any of those ones, or are you kind of strictly using the 240s?
Just the 240s, I believe, right now. Actually, I will ask our electrician because we're doing. I'll check with them on the small ones. I think we're using the larger draws though.
Okay. Yeah, the 120 volt heaters have been, sometimes a little smaller, but they're a little bit newer. I know Rheem and some of the other manufacturers haven't been making them very often. So now they're kind of making them a little more often. Condensate water pipe needs to drain. So Nick mentioned that you do need to have a place for that to drain. There are ways to vent this. I know there was a question in here about, say, pulling hot air from the room and putting cold air in. There are ways that you can vent this to the outside. So you can pull in air from the outside. You can put the cold air outside. Obviously, that's going to increase labor costs and increase materials. You're going to need the space to run this network of pipes, but it is a possibility. So the cost, there's lots of data around the cost, and it varies dramatically. As you can imagine, anything like this is going to vary depending on what model you buy, the size of it, the plumber you work with, and what the rates are, what rebates area will qualify for, so all these different things. But here's some kind of just general ideas. And these links are in the link that at the end of this, but there was a study from SDMUD. This is out in Sacramento, so this is in California, but they did a 3-year study, which I think made this really effective, as they looked at costs over 3 years, going from, let's see, it was 2018, 2019, 2020. I don't think they had 2021 data when they looked at this, but they looked at the additional the cost of converting. So if you currently have a gas system and you're converting to electric, it was around $4,155 all in. So this is installation and everything. If you had an electric system already, you can see it was a little cheaper, around $3,629. Mass CC. So here in Massachusetts, their estimates range from around $2,300 up to $4,300. So you can kind of get an idea of what you're talking about there. But again, keep in mind that operating costs are about 50% lower. So you are going to recruit some of these costs, throughout the operation of it. So now we can get into a little bit of how this, this is rebate. So I did just want to mention this. So the big thing I'm showing you in the middle are the mass save rebates. So mass save, I talked about mass save in earlier sessions because they have rebates for insulation and heating and cooling heat pumps. They also have rebates for heat pump water heaters. Right now, those rebates only apply in these specific situations. So if you're currently have an electric heater and you're switching from an electric heater to a heat pump water heater, or you use oil or propane to heat your water. If you currently use natural gas, which, as Nick mentioned, is probably most of you, the rebate currently doesn't apply. We're hoping this changes. The mass save or rebates are going to change in 2022. So we're hoping that'll be included and be one of them. But right now, that's not incentivized as much. But if you have electric or oil or propane, here's some rebates that you can get. Federally, however, there is an Energy Star rebate available, assuming that you buy one with the UEF, that energy factor. But pretty much any heat pump water heater that you get is going to qualify for that. They're going to be well over 2.2. And that's a $300 tax credit. There are some savings there. And here are a wide variety of different models that are available. This is just giving you an idea of what's out there, kind of what the differences are between them. You can there's lots of numbers. You can see that energy factor, that's the UEF I was mentioning. See, they're all, above 3 mostly. And you can see the cost down at the bottom. So that's giving you an idea of the range of cost for these different models. This you guys can have for reference. I'm not going to go through all of it unless you have questions about this, but I just wanted to show you some things that are out there. Now, here's a few other ones. I was mentioning you those smaller models. So you can see here, you have smaller. So what a lot of people will do, well, I don't know about a lot, but what some people will do is they will put these and use them at point of use places. So you may not replace a tank in the basement, but you may take an upstairs bathroom and put a point of use hot water heater there. to supply the water. And that's kind of what some of these systems are for. So you see a 7-gallon system, a 19-gallon system. They're a lot cheaper. They can be done at point of use, and you can, almost put them anywhere.
And one point on these, so the Bosch here and the Reliance and the Rheem, those are all resistance heaters. Those are not heat pumps.
Correct. Yes.
Right, yeah, those are just standard electric, but we use those.
Sorry. Electric heaters. You're right. They're not the heat pump style, but they're an electric heater. Sorry. Thank you, Nick.
Yeah. Okay, so there's a few. Why don't we take some of these questions and then go through a few considerations. So there was a few questions that came up, and then I want to talk through a few different considerations about to take in. So a question came up about noise. I didn't mention that here. So the heat pump water heaters do make some noise. I'll say it's sort of like a medium level fan when it's running. So they're not totally quiet. So you do want to think about that when we're placing the heat pump water heaters in our homes that we're building or remodeling, we don't typically put them directly under a bedroom. So if you put it under a living room, you won't really notice it. But you do want to be aware that if you're putting it right next to a bedroom, you probably want to think about some soundproofing or some, they're not very noisy. I don't know what the exact decibel rating is, but it's something that if you're a light sleeper and the heat pump turns on in the middle of the night, you don't want to hear it. So something to be aware of, but we haven't had complaints about it. You just have to be a little bit thoughtful. We also recommend, considering insulating your hot water pipes, to reduce the heat loss. Oh, sorry, can you go back? And some people want to know about when do they install multiple units. So a lot of houses, like Aaron was talking about, you might only need a small point of use that you use like very seldom. You might have a guest bedroom, or you have kids that come home from college and there's a bathroom that only gets used 5 times a year. So, a lot of times in our homes, we're putting in multiple water heat pump systems, but one will basically be dormant. So it's not heating the water up, it's pulling a little bit of heat out and it's holding temperature. They're fairly expensive. So that's where sometimes we'll do a mix too of resistance electric heating and heat pump water heaters. So, a lot of times, in New England homes, they have big boilers, and we used to put in these big indirect hot water heaters, right? So you have a big gas boiler and it's blasting out lots of, gas and making lots of hot water. And it's easy to pull an unlimited supply of hot water off of the boiler. And so when people say, well, we need more than 100 gallons of hot water, or we need 200 gallons of hot water, it gets a little tricky to do that all with heat pumps. So what we'll try to do is sometimes sort of zone the house with different types of heaters, like Aaron mentioned. You can use point of use. If you're not using it very often, it's not really drawing any electricity. So, and then we also do recirculation lines. So a lot of times, if you've got a long run from the water heater up to the place where it's being used, we'll put in recirculation lines. So if you're just replacing your water heater, it doesn't come into a factor. But if you're considering a larger remodel or new build, you want to look at recirculating lines. Another question too is, when do you choose to vent it to the exterior? So, Aaron showed 740 cubic feet. That's like a common number. If you put these heat pumps in a really small space, it'll drop the temperature down below 40 degrees. If you put it in a really small closet, and you don't want to do that because it affects the efficiency. So, how do you decide if you have enough room? Most basements, unfinished basements, are perfect. They're big open spaces, and there's usually a boiler or some other heat source, and it can pull the heat from and put it into the water. But if you're limited on space, so I saw a question about, multifamily housing and there's slabs on grade, you don't really have a place to put a heat pump water heater. You don't want to squeeze it into a closet. It's not going to work well unless you can vent it to the exterior. So if you don't have the square footage or the cubic feet of the airspace, you can go. If you go to the next slide, Aaron, there's a photo here of a ducted one. So this is a ducted heat pump water heater. We haven't had to duct our units, but basically, as you're cooling that air, instead of dumping that cold air into the room, you're dumping it into the exterior, or you're putting it into another space that has heating supplied to it. So just a few considerations, but the noise is not. We haven't had complaints, but it is definitely something to think about. There's another question about is the Co2 the only unit with the outdoor condenser? I thought we'll come back to that question. We're going to talk about a couple of those outdoor units after we go through a few more slides. So we'll come back to that question, Martha.
Yeah, just a quick slide here on water use reduction. So as we think about, changing out water systems and being more efficient, just thinking about ways to reduce water usage as well. So many of you may already have these things in your home, but good things to check on are faucet aerators. That's the thing on the left. It goes over all your faucets and slows it down. Low flow shower heads. They were probably a pain to use a decade ago, but the new models are great. Pipe insulation, so insulating your pipes. And then simply lowering your water heater temp settings. I mean, that's kind of a lot of them sometimes can go up to 130, 140 degrees. You can lower it down to 120 and have, water at a convenient temperature for you to shower or bathe or wash dishes and save on some heating that way. So there's just some things to keep in mind. But yeah, we'll go on to some of these other questions. So we have calculating. All right. So Nick, why don't you take us through calculating the kind of the usage a bit, and then we'll talk about this this Eco2 system that some folks have questions on.
Okay. Yeah. So a lot of times, like we talked about mechanical, when people go to change their water heater out, they're really not planning for it. They're sort of just like, oh, the hot water heater is busted, and they call somebody on an emergency call, right? It's like you're getting around that 10-year mark and you're not sure. So somebody commented in there that these are expensive and people can't afford them. They are kind of expensive right now for the early adopters. But if you can plan for it, it's worth planning for. So if you're thinking about this and you think, well, my hot water heater is okay, but I'm thinking, a year or 2 or 3 years down the road, how do I know what size I need? So this link on the energy.gov we'll show you how to size it. And Aaron, if you go to the next slide, we'll just show you some of the considerations. So how do you think about what size heat pump you might need, next year for your water heater, or 2 years? So you're not waiting for the water heater to break and then the plumber says, what size do you want? And you're like, I don't know. It's like that's the way a lot of these things get done. So the properly size it, you want to look at your first hour use. And so basically that's the amount of water that the water heater can deliver in the first hour. Okay. And so if we go to the next slide, so you've got to basically that first hour, or we'll call it your peak demand, which for most people it's in the morning when everybody's getting up and showering. So you're going to determine when during the day you need it, right? So is it morning, noon, or evening? What's the highest amount of water you're going to need with the number of people in your house? And then there's a spreadsheet at this link that'll show you how to calculate your usage. Okay, so and this can change, and that's why sometimes people say, well, I'm not exactly sure, or and some people want to have extra capacity, and some people feel comfortable cutting it a little close. So let's go to the next slide. So so this is the worksheet that they give you on. It basically shows you, an average shower. So a 2 gallon per minute flow rate will be 20 gallons of hot water. Okay, and so and then shaving is apparently depending on how often you shave, you get 2 gallons there. Washing your hand dishwashing, food prep is 3 gallons, and automatic dishwasher 7. Then you've got some clothes washing. So you could sort of fill this out and sort of say, okay, well, is it possible all these things would be running at the same time? A lot of times people aren't doing laundry while they're showering, but you could figure out what is your peak demand, or what do you want to be prepared for, okay? And how many times during that first hour, and then that'll show you this will give us the number. I've actually never filled this out myself. I've always just done what everybody else does, and call the plumber and say the water heater's broken. So this would be an interesting exercise. Let's go to the next one, please, Aaron. And so if you had 3 people waking up and 1 person shaving and 3 people washing their hands, that gets us 66 gallons we need in that first hour. Okay. If you had 1 person that decides they're going to take a 40-minute shower, now you've got to double that. You've got to add another 20 gallons, right? So if you do if some people like their showers and they do 40-minute or hour-long showers, and you're going to incrementally ratchet that up. So if we need 66 gallons, a 50-gallon hot water heater does not have 50 gallons of hot water in it. It's got about 35 gallons of hot water. About an 80-gallon hot water heater does not have 80 gallons of hot water ready. It's got about 50 gallons of hot water ready, and the other part is getting to temperature. So if you need 66 gallons, you might need an 80-gallon, and that might be cutting it close. You might need 2 80-gallon units. I didn't do the calculations. I should have done the check, Aaron, on exactly how much water does that first hour have on your standard 80-gallon unit. So I'll make a note to add that back in. But yeah, this is a simple spreadsheet will help you get to your, and then you can look at your recovery rate on the unit you're putting in. How much, what if the first hour, it's like there's 2 hours in a row and we have time for the water heater to recover. One thing to be aware of with heat pumps though is because they're slowly trickling heat into the water, pulling it out of the air, they don't recover as fast as just blasting a gas supply burner underneath the water heater. So we're used to like faster recovery times with gas, and we may just have to make some adjustments that hot water, it won't be as instantaneous if we won't recover as quickly. So it's a slight adjustment, but I think it's something that if you're trying to lower your carbon emissions, maybe you get used to not having as much hot water as soon as you need it. But if not, maybe you need 2 hot water heaters. Might need 2 heat pumps. So
it gets into that water reduction, quick slide as well on ways to do it. And I think it was Sue in the chat who mentioned, you don't need to do all this. This is assuming you're using hot water for all these tasks. You can wash your clothes in cold water, wash your hands in cold water, shave with cold water. You don't necessarily need to be using hot water for all these things. So keep that in mind as you go through these calculations.
I'm not going to recommend shaving with cold water.
Well,
but
as you can tell, I'm not as experienced. So,
but I do like I do the cold water for clothes washing. I just realized that was even a setting. Like I'm like, oh, I don't need hot water.
Oh yeah, yep.
Yeah. And then somebody posted a question: what's the recovery rate for a heat pump hot water heater? You got to look at the model, but I think in some of the models we showed earlier, I think it was about 21 gallons per hour recovery. But you got to look at your model, and the models will keep changing. So this is going to lead into this question about like capacity and on multifamily buildings. I got a call a couple months ago, or maybe it was 3 months ago. Brookline was looking at banning gas. And I said, well, I'm not really entirely for banning gas just yet, because what do you do in a big multifamily building where you need a lot of hot water and like the power goes out? We don't have a way to generate a lot of hot water quickly. So or what if we have people that really just want a lot more hot water quickly in their house and they don't want to be inconvenienced by having multiple units? So how do we increase capacity without adding a second unit? They make these heat pump water heaters where the condenser is outside. So instead of that condenser being mounted on the top of the unit and taking the air out of the space, they separate that condenser and they put that unit outside of the building. It looks just like your regular air conditioning condenser, okay? And this allows that condenser to be bigger, right? Because it's not like trying to be contained onto the top of a cylinder water heater. It can be, 3 feet by 3 feet, like a standard air conditioning, condenser. And the benefit of this is it doesn't cool down the interior space, because now we're taking the heat out of the outdoors instead of your indoors, and we're putting it into the water. So the Sandin units, which we'll show in the next slides, and the I think the Mitsubishi's we'll look at too. They're using a CO2 refrigerant in place of traditional refrigerants, which I'm not familiar with yet, but I've been hearing about some issues with those having issues in really cold weather. So Mitsubishi is launching. This is a commercial water heater that I think is coming out this year, and this is basically like a big heat pump for residential buildings. So go back to the question about a low affordable housing with basement on a slab on grade. You don't have a basement space. How can I get hot water? Well, this Mitsubishi system would be a commercial system that can will have capacity to generate a lot of hot water for a lot of units quickly. So this is one product, and this is also a CO2 based refrigerant. So a lot of the refrigerants are very environmentally damaging if they get leaked out into the environment. And so using CO2, it's environmentally, it's much less harmful. And so I don't know what the recovery rate is for these. These units are just coming onto the market, but I'm expecting we'll see these transfer over to the residential market. Aaron, can you go to the next slide? This is the Sandin CO2 unit. So these have been around for a few years, and I haven't installed any of these yet, but they are basically, you've got indoor unit and a big outdoor unit, and they have 119 gallons. So that's a pretty good capacity for for a big family or for a large household. But I have heard of basically because you're using CO2 as a refrigerant, I believe you're actually running the water outside and then back in, and then back into the building. So I'm not exactly sure how that works in really cold weather. And I would want to do some more research and reading up, probably on Green Building Advisor or some other site, about what are people's experience with these. This is a relatively new product to the market. And if people have used it, please chime in on the chat board. But I would do a little more research before I'd recommend one of these to my clients at this point. But bigger units, bigger capacity, faster recovery time. See that 69 gallons delivery in the first hour on this Sandon unit. So that's 3 times what we're seeing on those other indoor heat pump units.
Oh, this is just a link of some of the different resources we went through today, so you guys can check these things out. Few of them. So the Green Building Advisor, that's just a link to a direct article, but it's also just through the homepage of that link you can get to Green Building Advisor if you guys haven't experienced that. There's lots of great things on all these topics we've been discussing and a whole lot more. The third one from the bottom here is from the Mass CC. You'll see it there, scoclean.masscc. That's just a PDF guide of their heat pump water heater guide. Got a lot of good resources in there. So I suggest at least you check out those ones. But we have a lot of time here for some questions and discussion. I think we've gotten to most of the things folks have put in the chat room. Like I said, if you want to unmute yourself and ask questions directly, now's the time to do so. As in the meantime, we can kind of go through and make sure some of these questions are. Can I put links in the chat? Good idea. I will do that. Oh, sorry about that.
All the slides will be. Aaron, do you export this as a PDF when we're done, or you just put the recording on?
The recordings are posted now, but I can. I'll send out these slides here tonight to everybody. Register for this one, so you guys will get all these links. I'll send them to you.
And I was just thinking, I was remembering actually about over 10 years ago, we did install a solar preheater on a house, and I believe it actually worked pretty good. And I don't think there's been issues. I was just remembering, I said I've never installed a solar unit. Kate, I don't know, do you want to chime in on the multifamily solar hot water you're installing? I don't know if Kate's still with us. She's working on a multi-family building that's using solar hot water.
Looks like she's not on anymore.
Okay. Robert has a
question here about the circulation line. If Nick, you want to talk a little bit about that?
Yeah. So a couple things on recirc line. So basically, a recirculating line is you have a circular loop that goes from the faucet, from the hot water heater to the faucet or to the fixture. And what it does is when you call for hot water at the faucet or whatever, the shower head, whatever it is you're using, and if the water has been sitting in the line for a little while, it'll recirculate it back. It won't, it doesn't dump, it dumps the water back into the hot water system. And his question is it simple as having a pump installed, that more needs to be done? There's different types of recirculating lines. So what I would do is I would call a plumber and ask them if they're familiar with them. There's a couple different types. You can do some of them when we put them homes. You have a button you press, and what it does is when you press the button, it recirculates it. What you don't want to put in is a recirc line that just runs continuously, because that's very inefficient. Sometimes it's the only way for some of our clients to get hot water all the time whenever they want it. But for the most part, we don't want to have a recirculating line running all the time. It uses up a lot of energy. So we call it on-demand recirc, which is it recirculates when you want it, which is like, you either press a button or there's motion activated ones. So when you walk into your bathroom, it senses somebody's in the bathroom and it just recirculates, so the hot water is brought right to that room, and you don't have to wait a minute for hot water. I don't know.
Nick, a question here about ground source heating. Have you seen any systems that incorporate ground source into water? I know we have ground source heating for ground source heat pumps for heating air, but have you seen this for water at all? I haven't.
Ground source, I've seen them. We looked at it once for a preheater, so but we never installed it. So it's part of this. It's sort of like when people talk about heat pumps versus geothermal. It's just so much more efficient to go from air to air or air to water. than it is to use the ground. Let's say that the ground of the winter is 50 degrees down, at a certain depth, and you're preheating. You want to preheat water that's coming in at 40, or we've looked at it. It just didn't seem like it was worthwhile. It takes a lot of energy to recirculate the water. So long answer, no, we haven't done it. But yes, you can do it, but it's not common.
Yeah. It probably doesn't, maybe kind of like solar hot water, more common before these air source heat pumps have started to get on the market.
Yeah, and if you already had a geothermal system, or if you had a ground well, there'd be other ways to do it. But like I know that the project that Yana Silsby presented a few years ago at Passive House, Mass, like it was one of the Cambridge middle schools or high schools they built. They had drilled like 30 wells or something for geothermal, and so that would be a good on a big commercial project. I know it would make sense. On a residential scale, probably wouldn't make sense. I think I don't want to go off on a tangent, but in the future of like, as we get into this, places where you have a high heating demand and a high cooling demand, they're going to have technologies that will be able to match those demands. So like when you go to a grocery store and you've got a cooling refrigerator, but you're heating the space around that refrigerator, but it's cold outside, right? You're kind of have like all these mixed demands of like refrigerating in a heated space in a winter. There will be ways for the components to match those demands, but we're not there yet. So this is, I think, part of this presentation is that we're at the beginning of this transformation, and there's going to be a lot of new products on the market.
Yeah. You might have some input into this. Margie asked, let's see, kind of a difference between getting one yourself from, one of the big box retailers or going through a plumber. She specifically asked about the warranty. Is it better, with independent plumber versus the big box store? Have you seen any sort of variation in warranties or any sort of preferences versus how you purchase these?
I mean, the manufacturer warranty is going to be the manufacturer's warranty. So whether you're buying that water heater from Home Depot or you're buying it from your plumber, the manufacturer is going to stand by that warranty. But making sure that it's installed to the correct specifications. There may be a benefit, if you had an issue that a lot of times we tell people if our plumber supplies it, he'll warranty it. And whereas if I go and buy it at Home Depot and bring it to them and they install it, they're not going to warranty a fixture they don't supply. So, you might do some research. We provided a lot of links on the reviews of the different units, but for the most part, we haven't really, I think we've seen one issue with a heat pump water heater in the past, I'd say 6 years,
Okay.
We haven't seen a lot of issues with them.
Yeah. So to clarify the last one, in a sense, like the manufacturer warranty doesn't change no matter where you buy it. But if you have but the person who installs it might provide some type of warranty for their services.
Yeah. There's a question here too about, is there a place that rates the cold climate heat pump water heaters? I think the ones we showed you are the most common. We tried to put in the links reviews from a bunch of different sites that are reviewing them, because it's like, so I don't know one that just lists the northern climates, because ultimately you're putting these in basements across the country. So basements across the country are going to be probably a more similar temperature, like a basement in, North Carolina is not going to be that much warmer or colder than a basement in Massachusetts. Well, they don't even have basements as you get further south. So you know what, as I think about this, you don't even have basements in a lot of the south. So maybe it doesn't matter. So long answer, no, we don't have a list, but the list we did include in the links are multiple sites that are reviewing them. Yeah.
I think we're going to start to, Nick kind of mentioned this, a lot of this is new. So a lot of these systems haven't been in use for a long time. So we haven't seen a lot of in-depth reviews, but becoming more widely available. Eric has a question about, sorry if you missed this, but are these just domestic hot water for homes, or are these used in commercial projects? So at the end, we actually showed some examples of some that can be used in commercial projects. Probably this Mitsubishi one might be the best example that we've come across. Is that right, Nick?
Yeah, I mean, we're residential builders. So if you wanted to find out what they're using on the commercial side, I would probably, I'm trying to think who would be a good resource. I'd probably, I'd go on Green Building Advisor and ask Martin Halliday, or, or if you know Mark Rosenbaum, send him an email and say, Mark, what are they doing? What is the air to water systems for commercial buildings? I don't know, but there's people I would ask, or Mike DeClo might know. Mike,
good question. And I mentioned that
what are they
Mitsubishi
doing?
one just because that's the one that, Eric, I'm not sure if you saw those slides, you can review them later, but that's the one that has the condenser separate on the outside of the building. So that can be a little bit more common, I think, in commercial applications because of space regions, and you can put them on different floors that way and just have them outside the building. Nick, go ahead.
One thing I was going to say is thinking about backups, like when we have power outages. One of the reasons why having these hybrid systems is not a bad setup, or why I'm not sorry, there's a question here about how backed up contractors are, but I was thinking about battery powers. One of the things we have to think about is as we transition away from gas, like when they said in Brookline, I'm not 100% opposed to gas yet, because like banning gas in all buildings, because right now if the power goes out and you want to heat hot water, you don't have an efficient way to heat a lot of water, and gas is still like the easiest way to do it. Eventually we'll hopefully have batteries that can do that. You'll have a large battery that can then heat the water. The question, so sorry, that's I'm tired, so I'm off topic. For commercial buildings, Aaron, I was going to ask you, what are you seeing in the passive house multifamily? So like all these passive buildings that are getting built that are multi.
So for these larger residential projects, when you're getting into the passive houses that are going up now across the state, maybe 50 units, more than that, we're still seeing a lot of natural gas heating, to be quite honest. And that has to do with the fact that a lot of the systems we've been showing today haven't been effectively scaled up yet. They work well in a single family home, but we haven't really seen them working in these larger buildings. However, these stand-in systems and this new Mitsubishi model, I haven't seen the Mitsubishi model, but there is a multifamily project going up in Boston now that's using the stand-in system. So I think these are going to become more common for these larger projects. That's why I brought it up for the commercial one as well, because I think we might see them there as well. So again, we're at, I think, the beginning of this. We're starting to, as these stand-in like systems become more widely available, we'll start to see multifamily buildings kind of using them as the norm. I mean, right now, multifamily buildings are using heat pumps for heating and cooling pretty regularly. So I think it's only a matter of time till they're doing the same for water.
Yeah, there's a question about how backed up contractors are. I'm seeing that, just like with heat pump heaters, a lot of plumbers are starting to do these. This is going to become more and more the norm. And so, so we're, all the trades are busy right now, but I don't know if you call a plumber and you say, I want to put in, and they say, I want to put in a heat pump water heater. If they say they don't do it, I can give referrals. All the plumbers we work with obviously do them. So if people need a referral, I'm happy to refer all the guys we work with who are installing them. There's a question that don't most gas appliances need electric sparks like gas stoves? So if the power goes out, right? So yes, you need a spark, right? So just like when the power goes out and you need to be able to generate to light an appliance, you still need an electric ignition to light an appliance. But if you have a very small battery in a multifamily building, that is enough to run the lighting and the elevators and the smoke detector systems, and maybe you could run a battery to spark a gas boiler but not run the gas boiler, right? Like if the amount of energy you need to spark an appliance versus to run that appliance at full blast and to heat all that water are very different, right? The ignition is just a tiny amount of energy. The sustained heating of all that water with gas is a huge amount of energy. If we had to store all that energy in a battery, that would not be cost effective at this point compared to natural gas. So that's why, and so I think what they're doing in Cambridge as they transition away from gas in Cambridge, they're saying you can put in gas, but you have to have a plan to transition to batteries. So when that technology becomes available, to transition away from those.
All right. Nick, I have another question for you here. So thinking kind of in a home like I have, an old home in Massachusetts, unfinished basement. I still have a gas boiler for heat down there. If I were to put in, say, one of these systems, would I be concerned about the cold air going into the, near that boiler and just causing me to use more gas for heat?
No, I think this is a great application, a great use of so the old boilers aren't as efficient and they throw off a lot of heat because they're inefficient, right? And that's actually a good use of instead of just heating your basement walls, you can usually. So I have the same setup. I live in a 2-family and I haven't got rid of that basement boiler. So when I put in that heat pump water heater, that's a good use of that excess heat coming off the boiler. The bigger concern will be when I get rid of that boiler and go to heat pumps. now, I was talking with Kate. I was like, well, do I need to then put a heat pump in the basement to put air? And she goes, no, just run it on electric mode at that point. So the goal is to get to electric, ideally heat pump electric. But yeah, Kate was saying you don't need a secondary heat source. But we do in our projects, we do look, is there something that's generating a fair amount of extra heat that we can place, like in basements, a lot of the homes we're building, they have like these AV racks, so they have like a whole bunch of electrical components that generate a fair amount of heat. And if you can locate those near your heat pump water heater, great, you can use that energy. Or, so yeah. So if there is if there's extra heat being thrown off somewhere, great, let's locate the heat pump water heater near that space. Like also, this is something else to think about. We typically say we put our water heater down in the basement, but why do we do that? We do that because like that's where it was before, and it was, but with a heat pump water heater, why not put it up in the third floor closet space where all the heat is naturally rising, and that space is naturally going to be warmer. So if you do that though, you're up in your bedrooms, and then but I would float that idea, like putting a third floor heat pump water heater may not be a bad place to put it if it's quiet enough and you can put a pan to catch it if anything failed. There was another question: if the heating is gas-based in the winter, does this save gas usage? If the water heater cools the space, wouldn't the heating system work harder and use more gas? Yeah, it would. That's what it would, right? If you're taking heat out of the air, you're going to have to get that heat somewhere. And if you have a gas heating system, you're going to be using more gas to reheat that air. But the goal would be to get rid of that gas heater and switch that over to heat pump as well. There's also another question. We have a finished basement, which we use with an unfinished utility room in the corner. Is the cooling perceptible in adjacent rooms? Depending on what your heat source is. So if those adjacent rooms are heated and you have a heat source where it can call, so like you may not notice it as much. But if you don't have a heat source down there, and a lot of times in these old New England homes, we're just used to our basement being like 55 degrees, 60 degrees because the boiler is so inefficient, and there's all these metal pipes that are getting heated up above us, right? And they're radiating heat into that space. So you do want to think about it. I would say yes, you want to think about where is the heat coming from in these adjacent rooms? Because if those rooms are not independently calling for heat and they're not a zone, adjacent rooms are air source heat pump. Yeah, well then fine. You're just gonna your air source heat pump will put heat into the room, and your heat pump water heater will pick up some of that heat. And so that's a fine use. So you basically got two heat pumps working in tandem, which I think is fine.
Yeah, your electrical uses will even out.
Yeah, and that's what I'm going to end up having in my basement. So when we're going to put a heat pump in there, and then we'll have the heat pump water heater.
Right. There's a question about the on-demand water heaters. How do they compare? So I have an on-demand heater actually. So I think for an electric one, they're going to be. I think the biggest difference is just the efficiency. As Nick was talking about with some of those electric resistance heaters, an on-demand heater is going to work very similar. It just doesn't have a tank; it's heating on demand. But you're going to get about that one, UEF efficiency mark. Whereas with the heat pump water heaters, you're going to have it be much more efficient and go up to that, 3 or so. So basically, it's going to be about 3 times as efficient. So that's really the big difference. You're going to use more electricity on average for that on-demand one versus a heat pump system. I would say that's probably the biggest difference. I don't know of any offhand. There's also, I guess, on demand you have the time delay sometimes. But I've seen recirculation loops for on-demand systems as well to overcome that. That's all I see here, and we're up at 8 o'clock. Nick, any final thoughts? Thanks for staying here late with us tonight. Another exciting night of water. Yeah, thanks for the questions. And yeah, this is an evolving market. I'm not an expert on this. Aaron isn't an expert. We're all still learning about these products, and so if people have feedback and or if they're trying things out, we think this is the future, but we're definitely we're at the beginning of this transformation. So in 5 years from now, we're gonna have a lot of new products on the market. It'll be the dream would be we have instead of having 8 different heat pumps, like for your air conditioning, your heating source, we would have one heat pump that operated for the whole house and can independently send at the zone. So at some point, somebody will figure this out. We'll have one big heat pump, and that'll be our heating and our cooling and our refrigerator and our, and our dehumidifier and
our hot water heater, but we're not there yet. But the Mitsubishi, that I trust they'll figure it out at some point. But at this point, we're gonna have multiple heat. The New York feature are gonna have a lot of heat pumps sort of working in tandem, right? But that's more pieces of equipment, more maintenance. So,